viewers, welcome to Onison's tutorials. I'm Sir Amos. Today we are going to look at proving reduction formulas using integration by parts. So we want to take the proof to the reduction formula for sine. And the question says that prove the reduction formula integral of sine x raised to the power n dx equal to negative 1 over n sine x raised to the power n minus 1 cos x plus n minus 1 all over n times the integral of sine x raised to the power n minus 2 dx. So we want to show that when you integrate this, it will be equal to what? This. And so we use the integration by parts when we want to what? To evaluate, or if we want to integrate this particular function. Now, what we do is we say that we let the integral of sine raised to the power nx dx to be equal to, write it as the integral of sine raised to the power n minus 1 x, then times sine x dx. Now note that in the expansion at this side, sine x and sine x are the same base. This one is to the power of 1 n minus 1, while this one is to the power of 1. So if I multiply with the same base, I add the exponent. And therefore, if I add the exponent, I'm going to have n minus 1 plus 1. And that will give me n. So this side is technically the same as this side. You will still have sine x raised to the power n difference integrated with respect to x. And now, we will now take this particular side and then apply the integration by parts formula to evaluate it. And so we say that using integration by parts, we have the integral of u dv to be equal to u times v minus the integral of v du. So this is the integration by parts formula. Now let us compare what is here to what we have here. When we are comparing it, we would realize that we have the first one is sine x raised to the power n minus 1. So we let that one to be equal to u. So we say let u to be equal to sine raised to the power n minus 1x. So that if we differentiate this, and how to differentiate this? We differentiate this by using apply the chain rule. Now, to differentiate this, we differentiate the outer function and then multiply by the derivative of the inner function. Note that I can equally write this one as, I can write the sine n minus 1x is the same as sine x raised to the power n minus 1. So once you know that this one is the same as this, or this is the same as this, then we have the inner function to be sine x, and the outer function is equal to some function, let's say u raised to the power n minus 1. So using the chain rule, we differentiate the outer function. So that is going to be this times the whole of this one. So I get n minus 1 multiplying u raised to the power n minus 1 minus 1. I will subtract 1 from the power to obtain minus 1, 2. Then I will multiply it by the derivative of sine x. And the derivative of sine x will give us cos x. But the u here is the same as sine x. And so we are going to obtain the derivative of this as du dx to be equal to n minus 1 multiplying sine raised to the power n minus 2x. Then times the derivative. This is the derivative of the outer function. Then times the derivative of the inner function with the derivative of sine x to get cos x. So from here, I can make du the subject, and therefore we have du to be equal to what? N minus 1 multiplying sine raised to the power n minus 2x cos x then dx. So this is equal to what? Du. Now if we represented this u as sine raised to the power n minus 1x, then the remaining one will be for the divine. That is here. So we have divine. U is this. Then it means divine will be equal to this. And so we have divine to be equal to sine x dx. So therefore, if you want v, we take the integral of both sides. So v will be equal to the integral of sine x dx. And so this one will give us negative cos x. This will give us negative cos x. So finally, we have v as negative cos x, and we have u as sine x raised to the power n minus 1. So we put them into the integration by parts formula. And so therefore we have the integral of this is u, then tan divine to be equal to what? U times v, and u is what? This is u, so we have sine raised to the power n minus 1x times v times v, and v is negative cos x. So this will give us times negative cos x. Then minus, that is here, the integral of v to u, minus the integral of v, and v is negative cos x. So I have negative cos x times the u, and u we said should be this. This is the u, so we put the whole of this one for the u. And so we have times n minus 1 sine raised to the power n minus 2 x, then multiply by what? Cos x, then dx. So we have this to be the expansion after we have substituted in the u and the v into the integration by parts formula. So let's simplify this. But we know that this one was an expansion of this one. So we can put it back. And so we have the integral of what? Sine raised to the power nx dx, which is the same as this, to be equal to, this one will give us negative sine raised to the power n minus 1 x cos x because of this negative. Then this negative times this negative will give us plus. So I plus the integral of cos x, then n minus 1 sine raised to the power n minus 2 x, then times cos x dx. Now let's look like that. So this will be equal to, we have negative sine n minus 1x, then cos x. Now n minus 1 is a constant, so we factorize the constant n minus 1 out. So we have plus n minus 1. Then we have the integral. This one is cos x. So cos x times cos x will give us cos squared x. So this will give us times cos squared x. Then times sine raised to the power n minus 2x. Then dx. But we know from the trigonometric ratios that cos squared x plus sine squared x is equal to 1. So using that idea, it means that we have cos squared x. If we make it the subject here, we have cos squared x to be equal to 1 minus sine squared x. And so I will substitute cos squared x by 1 minus sine squared x into this. And we have negative sine raised to the power n minus 1x cos x plus n minus 1 times the integral. So cos squared x will be replaced by this. So we have minus 1 minus sine squared x, then times sine raised to the power n minus 2x dx. So moving forward, we have negative sine raised to the power n minus 1x cos x plus n minus 1 times the integral. So we are going to multiply the whole of this one, whatever is outside the bracket, by the inside. So we have 1 times this one to give us the same thing. So we have times the integral of sine n minus 2x. Then I multiply sine x raised to the power 2 by sine x raised to the power n minus 2. And now the bases are the same. So we are going to add the powers. So adding the powers, we have 2 plus n minus 2. And that will give us n. So it means that this one is the same as minus n minus sine x raised to the power n. This one will give us minus sine x raised to the power n, then dx. And so moving forward, I have negative sine raised to the power n minus 1x cos x plus n minus 1. Multiply these two out. So I have this times this, then this times this. But this is a difference of the integral of a difference of two functions. So the integral affects each of them. And so this will give us n minus 1 times the integral of sine n minus 2x with respect to x minus n minus 1 times the integral of sine raised to the power n x dx. So finally, we have this to be equal to this. But when you compare the left hand side to the right hand side, we have sine x raised to the power n and we have sine x raised to the power n. So we can group like terms by taking this one across the equal sign to this. So we have the integral of sine x raised to the power n dx. Then plus this. This is minus. So if I bring it across the equal sign, it becomes what? Positive. So plus n minus 1 times the integral of sine nx then dx. So this will be equal to this negative sine n minus 1x then times cos x then plus the remaining one, which is n minus 1 times the integral of sine x raised to the power n minus 2 dx. Good. So this is what remains. If I bring this one to this side, it remains that. So now from this side, the left hand side, let us do some manipulations here. The common term there is sine x raised to the power n. Sine x raised to the power n. So I can factorize the common term, which is the integral of sine x raised to the power n out. So if I factorize it out, what will be left here will be 1. Then plus n minus 1. That's this side too. If I factorize it out, I will be left with this. So it's now the whole of this one times the integral of sine x raised to the power n, then dx. I take this side again. I have factorized the integral of sine x raised to the power n out with respect to x. So I will be left with 1 here. And if I take this one out too, we will be left with n minus 1. So we have 1 plus n minus 1, then the x. It has been factorized out to be equal to negative sine raised to the power n minus 1x plus x plus n minus 1 integral of sine x raised to the power n minus 2 dx. So this side becomes 1 plus n minus 1. So this side becomes n times the integral of what? Sine nx dx to be equal to negative sine x n minus 1, then cos x plus n minus 1 times the integral of sine x raised to the power n minus 2, then dx. Okay, so from here, I will divide both sides by n because we need this, which is what was required here. So if I divide both sides by the n, I'm going to have, therefore, I'm going to have the integral of sine x raised to the power n dx to now be equal to, that is, I'll have negative 1 over n if I divide here by n, then times sine x raised to the power n minus 1, then I have cos x, then plus this side too becomes, dividing this by n, I have plus n minus 1 all over n minus 1 all over n times the integral of, we have sine x raised to the power n minus 2, then times dx as what required. So when you finally compare what we have obtained here with what has been given in the question, it is exactly what is required. And so we have proved the reduction formula that this one is equal to this. Okay, so kindly subscribe to my YouTube channel, watch, like, comment, and share the video. Thank you.